So guys, we've been now going over account concepts, resource concepts, consensus. There's a very little left now. This section is all about kind of chain governance and the chain customizability. So each chain, so USA architecture has several what are called system contracts that define the rules of the chain. And so the main one is called EOSIO. If you go into EOS Studio, you can type in EOSIO, and you can see a lot of the functions and actions that we've been talking about, like new account, set code. These are all defined in that contract itself. There are several other support contracts, like EOSIO.token. This defines the currency in the system. This allows for asynchronous authorization of messages and several other things. So who is the owner of the chain is defined by the account permissions in the EOSIO account. And what's cool is that this on-block action can automatically update those in a dynamic way based on whatever you define, some sort of voting mechanism, maybe it's some kind of weight based on wealth, or if you have an identity system in there, you know, a democratic system could be built. So these contracts basically define a lot of the functionality on the chain, the rules. So consensus, like I've just been saying, they define how accounts can be created and what permissions they have, what the names they can have, so who's allowed to have what names, and what the structures they're allowed to have in their permission hierarchies and how that can be structured. So these contracts also define the system currency, which is at EOSIO.token by default, and all of the rules around that, who's allowed to transfer them to who, how are they created, you know, any kind of rules. The rewards the block producers get based on producing blocks are defined in the system contracts as well. So you can customize, if you have incentivized block production, that is, who gets how many rewards based on how many blocks they've produced. Yeah, I said there is, I mean, we've seen today that you authorize a transaction at once. That's easy when you've got an account with one public key. If you have, for example, an account with 600 keys, it's very hard to organize all of those signatures at one time with one transaction. And there's a feature built into this to do that asynchronously, and that's part of the system contracts. And also the mechanism for upgrading and deploying contracts is that set code, set ABI. That's defined in the contracts. You can customize that as well. You can declare rules. You could make upgrading contracts on the chain not possible by basically make that function throw an error. You could make it so the system contracts have to undergo specific extra criteria for them to upgrade, all these kinds of things. And there's also a kind of backdoor function that allows the system administrator to bypass authorizations if they want to. And that's been built in as a feature to allow the administrators to have control and maybe upgrade contracts if they've been broken. If somebody loses their keys, they can replace people's keys. They can kind of bypass the authorization checks. So they can turn that on or off or whatever they want to do if that's needed. And you can create auxiliary kind of governance stuff, whatever you want to do to have the governance of the chain. So what is very innovative about EOSIO compared to previous blockchains is that so many of the rules are defined in these system contracts, right? And that means that upgrading those rules and changing those rules is both straightforward, transparent, and easy, right? Because you just define it in contracts themselves. You don't actually have to modify the protocol to change the configuration of the chain or to upgrade the chain. So smart contract updates, because they're transactions, synchronize across the network at the same time. So that means to upgrade the rules in the chain just mean you need to satisfy the EOSIO permissions, a supermajority usually, to upgrade those rules. So in previous blockchains like Bitcoin, Ethereum, to do this you need something called a soft fork, and people can, you often need a hard fork actually for most of the rules, but in this case, some of the rules in previous blockchains can be upgraded by a soft fork. The difference here is that the changes done in the system contracts are synchronized across the entire network, and that's not the case for a soft fork. In other chains, because they have less customizability, most things need to be a hard fork. They actually need to change the protocol software themselves. So that is also needed for EOSAO changes sometimes. So that could be to update the core consensus model, the ABFT, or it may be to add new intrinsic functions to WASM and some other things. So there are situations where the core software needs to update, and this would be kind of the hard fork equivalent. The thing is that these are less needed in EOSAO chains because more is done on the system contracts. So the way these two upgrades work is upgrading the system contracts is just done through a regular contract upgrade, which synchronizes across all nodes instantly. If you want to upgrade the node software itself, you need to get all of the participants in the network that have the EOSAO permission. You need to get a supermajority of them to upgrade their software. And then they need to call a special activate function. And this will activate features built into the software, and that will synchronize across the network at the same time. What will happen, though, is that any node in the network that hasn't upgraded their software will then stop syncing automatically. So these two mechanisms provide a much better synchronization technique to previous blockchains, which cannot upgrade as many things as easily or need a full protocol and software update across all of the nodes in the system for this to actually synchronize. So this is one of the huge, I think, one of the real exciting things about this is that you can really play with governance and you can allow chains to govern themselves in much more flexible ways and in ways that they can actually try out and test and iterate on quicker than in previous chains. And it's also just more manageable and transparent. So because, like I said, because these rules are on-chain, the chains are super customizable. They can easily upgrade. All the rules are transparent, so people can more easily and tangibly see the rules because they're in smart contracts, not in program protocol code. You can just see what the rules are by looking at a smart contract. It means that all of these different chains that are completely customized, that may have completely different rules, actually can talk to each other with the exact same language, the EOSAO protocol. That protocol really just defines the ABFT consensus mechanism and a few structures. The rules for the governance are in smart contracts, so they're all very compatible, and that's why you see, a block explorer like Blocks is able to manage all of those different networks with just one piece of software, without changing that software at all. And that also makes the interoperability between chains a much easier problem to solve as well. So interoperability between EOSAO chains is an easier problem than it is between other multi-chain ecosystems because they're so much more compatible. So I'm going to talk about the first blockchain, EOS. The EOS blockchain, the first blockchain powered by EOSAO. So it's not a very good blockchain anymore, in my opinion. So they've built some rules in the system contracts that have allowed for kind of a massive amount of vote gaming and manipulation and lack of governance. So problems that they have, I'm not going to say that these are the exact reasons, but these are contributing to it, is because you can vote for 30 producers at once. It means that there's a lot of in-voting happening. There's also a proxy capacity where you vote for a proxy, and then they vote on your behalf, so people are bribing those proxies as kind of more centralized points. They've got an extremely complex resource management system with staking, delegating, renting, and all kinds of other things. And that's led to a very interesting denial of service attack that's ongoing right now. It's been going on for about 8 months on the EOS blockchain, where people are using up all of the resources on the network, and it makes it hard for anybody else to use. And also, something that's happened is because you can buy your way to the top, basically the big exchanges are doing this. And then they get the rewards in EOS. The problem with this is that those big exchanges, this is not their primary line of business. Their primary line of business is their exchange, and running an EOS node is secondary. So they don't participate in governance in the way they should be. They're not actively upgrading the network to fix problems and looking at the network to determine if there are problems. So the good news in EOS, the blockchain protocol itself is still running well. Like these exchanges, I still have enough incentive to run a performant node. That said, there is a denial of service attack in the form of a smart contract that's crippling the resource allocation on the network. And the governance issue is not allowing them to identify, acknowledge and then fix it. So yeah, EOS at the moment is having a lot of problems. It's had them for quite some time now. And it's, in my opinion, not a great blockchain at the moment.
How do you think they could break this problem?
So Telos is another blockchain run by EOSIO, and they've made several modifications to those system contracts that try to mitigate all of these issues that have happened on EOS. It's a big reason why Telos exists, because they predicted these issues correctly and have built a bunch of different rules that at the moment have not resulted in these problems that you see on EOS. So one of the things is the token distribution. When it starts off, limited people, so it cut off a lot of the weight that the cryptocurrency exchanges had at the beginning of the network start. So they don't have as much centralization of wealth. They have a different voting protocol that doesn't allow, that I guess incentivizes less in voting between different block producers. They have an on-chain dispute mechanism, arbitration process, so that's interesting in itself. It's kind of trying to be something that self-regulates. I wouldn't call it a super successful use at the moment, but it's there and they're playing with that. They have an automatic removal of block producers based on performance. So if they don't produce enough blocks or to the high enough quality, they'll just get booted out automatically. And fairer system and payments for the block producers themselves. So lots of different rules there. So it's important to talk about how the BPs get paid, the block producers get paid. What are the rewards? Why would you run one of these nodes? These are quite resource-intensive pieces of infrastructure, these nodes. So I'm going to talk about Telos. So basically the way that it works is that every year the amount of tokens in the system inflates by 2.5%. So if there's 1 billion tokens right now, in a year there'll be 1 billion plus 2.5%, yeah, whatever that is. And so 1% goes to producers. That gets split into the top 21 producers plus a set of standby producers that are ready to jump in if they're voted into the top 21. And they've set up an algorithm that makes the pay gap between number 21 and 22 quite flat. So in other blockchains, I know like in Lisk, this is a very big problem. If you're at that gap of who's producing blocks and who's not, then they have this big gap wealth. That means jumping that gap is actually quite a big financial risk. So another part of their
financial risk.
Yes, because you don't know if you're going to get paid a lot more until you invest a lot more to get there. To get more people to vote for you.
Right.
This is
Here, it's if I'm a standby block producer, I still get.
This is how delegated proof of stake works. These guys get paid because they're voted in. Like I said, you can build a proof of authority network or something else, and then it would be probably quite different. But in a permission, this is a permissionless system. Anybody can be a block producer if they're voted in enough.
Is this the same for EOS? Like, or different numbers?
I'll talk about that in a sec. So importantly, 1.5% is put into a different savings account, and that funds the worker proposal system. So two things. Firstly, Telos has changed the system to have no inflation, and they're using an old fund that they had at Genesis, and that's probably going to run out in about 2 years. So this is quite exciting to have a zero inflation blockchain paying for producing blocks for free. There's limited tokens. So the whole point of this is so those transactions are free. You don't actually have to have your balance reduced of how much tokens you have every time you send a transaction. And that free transaction capacity is a much better user experience for most people than in Ethereum or Bitcoin.
Does this open the network up to a spamming attack?
Yeah, to some extent. That's why you have those resource management. And there is spam on these chains, but it's manageable. It doesn't, cripple the network.
But when it gets big, don't people want to spend it? Spam is relative on how powerful you are. If I'm a hacker, I won't, or if I'm a joker, I won't attack you, Jack, because
yeah,
but if everybody here starts using this stuff, then suddenly you're very interested to troll or to attack.
Yeah, it is possible to spam networks, but it depends on how these system contracts have defined the resource allocation.
I think also these networks of blockchain, you need a lot of resources, so it's not affordable. Like he said in the past, like to make an attack on certain blockchains, either it's proof of work or proof of stake, you need so much resources that it makes it not profitable, unless you want the only
But you
to destroy the blockchain.
You can. It's also possible to design your smart contract system that it's not profitable to spam it, and that's what most people do. So there is kind of spam in terms of data on the blockchain, but not in terms of like gaming. Yeah, that's kind of more attacking consensus. That's not possible with this kind of thing. So there's different kinds of security vulnerabilities. Spamming is kind of just putting data that people don't want to see. Actually, attacking consensus is a very different concept. And that depends on the system contracts, how they've defined the governance of the chain. So, I don't know, in EOS, just to comment, they have a 5% net inflation that they've just changed to 1%. And again, they have 1% producers, 0.25% to the 21, and 0.75 to standby producers. And they don't have a funding proposal system.
Does that number go up over time, or they're just going to try and keep it?
Yeah.
They're going to try and keep it.
I'll take another answer.
But this is going to last 2 years. They have a fund that's funding this instead of having inflation rate. After that, they'll have to put this back to 2.5%. So this is a really cool thing that is on Telos. They have this Telos worker proposal system. So this is a DApp on Telos that you can use and that I've used several times. What you can do is you can submit a proposal. It's got a name, it's got a PDF in it, and it's got how much you want to be paid for it. So I've submitted several of these proposals in the past. And if it reaches a certain quorum, then you get paid the amount that you propose in the proposal. And yeah, people vote on this in Telos based on the amount of Telos that they have, amount of tokens they have. So generally there's like $500,000 worth of Telos voted on each proposal. So you want to make sure, if you want it to pass, you want to deliver a lot of value at a reasonable price, and then people will vote for it.
But this comes out of that 2% saving, or 1.5% saving.
It comes out of that special savings account.
Yeah. So it doesn't actually cost them anything.
Yeah, because they could spend it on other things.
Yeah, okay.
There's an opportunity cost. So they want to make sure they're balancing what. But the thing is, it's a decentralized funding mechanism without anyone governing it, which is kind of cool. So I've had my 3 previous workshops of these funded by it. I've got one for this workshop, but it's not going to pass, unfortunately. They haven't voted for it this time. Yeah, and that's a good question. I think they've changed priorities. And there's also other competitors teaching as well. A bit more.
Next time send us to vote.
Yeah, well, yeah, I need like $500,000 worth of Telos. Unless you got a lot of Telos, it's
Oh, but every,
Yeah.
has a-
so. I mean, this is the system. If it goes through, then I just get paid, or whoever gets paid. It's pretty quick. If it's not available, then that payment's queued for later. If it doesn't quite get the quorum, but it doesn't do too badly, then I get my fee refunded. There's a 3% fee so that it doesn't have spam. So very easy.
So in order to commit the proposal, you need to have 3% fee.
So I need to pay a fee in, and if it doesn't go through, then I won't get that fee back. Right? Then I don't get my fee. So that's how they've done spam protection in this system. So there's ways to build in spam protection. And yeah, there's no spam in the system. That 3% fee is solid. Yeah.
So people actually have to review these proposals. They're actually
Yeah, the investors of Telos who have Telos tokens review it.
But these proposals, like, they have like an expiry date. You can put
They're all 1 month.
1 month.
So there's a 1 month voting period. So mine is still ongoing. It'll stop at the start of March. Right now it's at 70% no, so it doesn't look like it's going to pass. And I'll get my feedback probably. But I've taken a lot of Telos stuff out of this presentation because it doesn't look like it's going to pass.
How about fitting in a proposal for demos or stuff like that?
Yeah, I mean, that's in there. You should have a look. There's a link up here.
Yeah, we should do one together.
Yeah, have a look here. You can see all of the proposals. Right now, I go to governance. These are all the proposals on there right now. If you click on details, here, I'll look at my one. Here. Check out details. This is a PDF. It's uploaded to IPFS, the Interplanetary File System. So everyone can download it. I've requested 20,000 Telos, which is about $1,000 US, to cover catering for today. I would have bought the pieces for everyone.
There is a specific procedure to make the PDF or everything? Or?
Yeah, I could directly interact with the blockchain, with the smart contract, but they've built an interface for me, so I just do it through that. Yeah.